Welcome back to another episode of Solar Beyond the Datasheet. I'm back with Dave Wilson, the owner and founder of Greenfrog. And in the last couple of episodes, we've briefly spoken about tech. And today I wanted to do a deep dive into tech, more so than the first couple of episodes, to really understand more about where we started, where we are now, and where you think we're going to go.
Okay.
So I guess my first question to you is, when you first started the company, the technology by today's standards was vastly different, I would imagine. I mean, back then, what were you looking for? How did you look for it? You know, so many questions.
Okay.
Right?
Yeah.
So do you want to give me a bit of an insight into how that all started and, you know, your supplier journey and technology journey?
Yeah, I guess when you think about the fundamentals of a solar light, probably let's break that down and then we can talk about the tech in relation to each part. So you obviously have a solar panel, and those are mounted on some sort of rigid frame, it's designed for the environment. Then you'll have LED, light fixture, obviously mounted to the pole, cables, all that sort of stuff. Then you'll have batteries, and then you'll have a controller, and then it's all kind of bolted in the ground with the foundations or the footings. So if we start at the top, solar panels. So back 15 years ago, designing the first ones, they were obviously much smaller solar panels by then. So I think one of my first projects was about 140 watt solar panel, and that was running a LED light about 30 something watts. So obviously, solar panels have evolved back then. LED was very interesting because back then, a lot of the LED fixtures hadn't really evolved yet.
Oh, okay. Right.
So like now you go look at an LED fixture and they're kind of square or rectangular or whatever. Back then, we were still retrofitting old sodium type lights. So the fittings were quite large, and then you're essentially shoving an LED light engine inside of one of those. So my very first lights were retrofitting an older type design. That was still quite modern, but it was essentially a retrofit.
Right.
Then we would have had the pole. Poles really haven't changed too much, to be honest.
Okay.
A lot of the standards have increased over the years. So the amount of pole rigidity and things like that. Same with the foundations. But then we have probably the controller is probably one of the biggest changes. Back then, the controllers were, for example, the very first generations weren't waterproof. They were on the market, so we had to spend a lot of time waterproofing them. And then obviously, they weren't designed for temperatures. So it can get to 50, 60 degrees, 70 degrees inside of a pole. So designing for all those with bigger heat sinks. So that was a bit of a challenge. And back then, the reliability of the drivers, the LED drivers, that essentially give the right voltage and the current, so the LED doesn't burn out, essentially. Look, LEDs in summary, they're not like a normal bulb. You just put power to it and it does its own thing. LEDs, if you don't have some sort of regulation, they'll just get brighter and brighter and brighter until they blow. And all those circuits were all still new.
Right.
So they were unreliable. So we had to spend a lot of time engineering those in. Batteries, very, very first ones were AGL or gel AGM, glass mat batteries, mounted in the bottom of the pole, and, small capacity batteries, and then, wiring them in the configuration so that the light would work. So that's probably where it was back then. And then all the systemic issues you have to deal with is trying to get them to survive for a long period of time and trying to get them to work underwater.
Yeah, right.
Or just getting to survive the extreme temperatures in Australia. So, yeah.
So in terms of, AC versus DC, was it difficult to find DC stuff back then?
It's like I said on previous episode, was a lot of the industry was still geared around grid tied. And even a lot of the competitor technology was grid tied. So even though it's got a battery and it would have an inverter in it to run a light fixture, and inherent by nature, the only people licensed to actually fix it would be sort of someone like me. Someone's actually a licensed electrician.
Right.
So that makes it really difficult to send somebody out middle of nowhere to fix. So a lot of the tech was still grid tied. We certainly did pioneer a lot of the work in designing all the electronics in the early days to only be low power for that exact reason.
Yeah.
So one of the interesting things is with grid tied systems, especially when you power them off low voltage, it attracts a lot of insects, bugs.
Right.
So
Because it's warm, right?
because it's warm.
Yeah.
And just I think the whole voltage, like the field, the EMF field it creates, attracts insects and mice and vermin. So it's really interesting.
So, I mean, back then it was a different industry, really. Solar panels were small battery technology,
Yeah.
not so evolved, and a bunch of other things. From our perspective, Green Frog's perspective, what were those key design elements you were wanting to implement into your systems even back then to make sure they do work in extreme temperatures or underwater? Did you have that in mind, or did that kind of evolve over time?
I think as a design sort of engineer, you think about it during your design, but it's not until years later you figure out if it worked or not.
Right.
And a lot of that was because a lot of the tech we have their own individual data sheets. So solar panel says we can run up to 80 degrees, or battery we can run up to 70, or controllers. But it's still, when you put them all together in a harsh environment where it may have a lot of humidity or just be really hot, or inside of a pole, they all behave differently. So it's that, oh, okay, I've got a problem, like my controller's overheating. How do I fix that even though the controller says it's rated to 80 degrees? So you end up having to fix a lot of things. In the early days, taking somebody else's component, making it better, changing it. And like I said in the previous episode, that's part of the reason why we design our own stuff now. Because it's kind of purpose built for what we need to do.
Yeah.
And I think that's the key, is at some point in our industry, because there's a lot going on with a solar light. There's a lot going along with a remote energy storage system. You've got a solar panel, which is generating electricity. That energy needs to be regulated. I've got a controller that's doing that regulation, but it's also looking at a battery. It's then trying to make sure it doesn't overheat the battery. It's trying to make sure it can charge it quickly, but not charge it that quick to damage it. It's then working out what's night and day. And it's then powering another load. So we'll then have powering a light fixture. And remember I said the light fixture has to have its own regulator so it doesn't blow up on you. So there's a lot going on. And then you put all that in a really harsh environment and you expect it to last 10 years. It's not easy.
No.
Yeah.
And I mean, you also mentioned last time that for many of our lights in those critical infrastructure environments, we have a higher uptime than grid-tied light, which is fascinating to me, and one of the stats that I'll remember forever. In terms of the engineering and the testing that we do, what are the critical elements for you to make sure that it has that longevity out in the field?
Yeah, good question. Notice we've got a little mini cyclone running through the place right now.
We do. Hopefully we're here for a bit longer.
Yeah, hopefully the roof doesn't come off. But I think some of it is incremental testing over a long period of time. So I think one of the first products we identified early on in our 15-year journey was the battery.
Right.
It's really the heart of the system, and it's had the most upheaval in the industry. It's had the most change in emerging bleeding edge technologies or whatever. There's always something new. I mean, every day I'm seeing new stuff come out. But that to us has always been our fundamental building block of the batteries. One test that we constantly run, and we ran this test for 2 years non-stop,
Yeah, right.
where we got one of our heat chambers. So we would heat the battery up to 65 degrees, and then we would rapidly charge the battery, and then rapidly discharge the battery 10, 15, 20 times a day. So that 10 times a day is simulating 10 days.
Yeah.
But we did that constantly for 2 years. And we'd pull the battery out, and then we'd test the battery. And then we build all these different models with how much are we pulling a little bit out of the battery every day, or are we pulling a lot? So I can't imagine what the electricity bill was, but we were basically running a heater 24/7 for 2 years because we needed real data on what our batteries were going to be doing in 5 or 6 years. And it's like I said before, I can pull a data sheet off somebody's battery and I say rated for 2,000 or 3,000 cycles.
Yeah.
But you don't really know.
Is it real? Yeah.
That's the big.
Yeah.
The only way you know is to actually test it. So we do a lot of testing with that, and imagine we do the same thing with our controller. We even go low temperature due to demand and clients up in Canada and Alaska. So we go high temperature, low temperature, long-term field tests. I mean, our facility, our R&D facility here in Adelaide's got lights and fixtures that have been there from day dot, where we just constantly like to just see how things survive in the elements.
I always find it fascinating where sometimes a new piece of technology comes out and there's a warranty period on it. And you think, is this thing going to last, being a completely new piece of technology, and you don't necessarily know the testing that's gone in behind it. Whereas obviously with what we do is stringent here in the R&D facility. Have we backed that up in the real world?
Yeah. We've got certain key customers around the world, and we kind of got a little agreement with them where they're our mini R&D sites. So we'll periodically go back there and change the battery out. We had one recently up in the middle of Australia, and we pulled one of our Aspire batteries, which is a fully encapsulated, fully waterproof battery, out of systems that well above 60 degrees, 70 degrees in summer. And these have been in over 5 years. So part of our R&D, we went up there, replaced the batteries, brought them back here, and they just finished going through a bunch of testing. And we were in what is the harshest of harsh environments we could put them through. They were still retained well over 80% of their original power capacity after 5 years. That's what it's designed for. And sometimes no amount of lab work really tests that. And so we do rely heavily on that. Would be ongoing testing with a couple of our key clients here in Australia and the US, and even the UK as well, which helps us design better products.
And one of the benefits, I suppose, of being around for 15 years just focusing on solar and generation and battery storage is that we do have that real world data to back up the testing.
Yeah.
Whereas, sometimes, like you said, looking at a data sheet, it says one thing, then you put it into practice and something completely different happens.
Yeah.
Right? Or the data is not necessarily backed up.
Yeah.
So 15 years ago, the technology quite different, and along the journey, obviously it was upgraded and different models. where is it today by comparison to back then?
It's vastly different now. As solar-based products becoming a little bit more mainstream, and that's basically due to worldwide people becoming more educated on solar. I think I said in my previous episode, back when I did all my engineering and electrical theory, the word solar never even came up. I had to go figure that bit out for myself, or with a lot more study. Whereas now they teach that,
Right.
they just, it's one of the first courses they teach, and clients are educated with media and marketing as well. So the technology is really going to the point where customers are demanding more because they're seeing the technology go in another space. So for solar lighting and solar energy storage, they're wanting data. They're wanting data on the performance of the system. Also for, everything from carbon credits offsetting to CO2 offsetting, we have the data to give the customers. Probably one of the most reliable sources of information for the industry in the world would be coming from our databases because they're long and well established.
Yeah.
So I think from a business perspective, people are using us to offset carbon generating technology. So we're a true offset. So that data is very important to them. The definitely, when I think back, my very first installs were more around security lightings and pathway.
Yep.
Our business has evolved into mission critical applications that I love to follow, which is dangerous intersections, roadways.
Yep.
Or powering really critical pieces of devices up that just have to work. Everything from perimeter security to high-end surveillance systems to long-range Wi-Fi, which are critical. People are wanting that telemetry, and they're wanting a system that is ultra reliable.
Yep.
So most of our tech now is building in redundancies in for solar panels, for controllers, and that's flowing back into our mainstream products as well.
Yeah. Okay.
And the more need for more smarter based adaptive systems. So systems can AI learn what was my weather like this time last year? What's it going to be this year? And these are all the amazing stuff we're working on now, is all that predictive power, so that if you do have something really critical that needs to be powered, it can start to store before the event because it knows what happened this time last year. Yep. So that's probably where the industry's going.
Yeah. Okay. And in terms of what we can power now, has that changed over the last 5-10 years? You started off powering solar lights, and now you've mentioned a couple of other things.
Yeah.
What were those critical changes that allowed us to do that?
Yeah, sort of 13, 14 years ago, we were powering cameras, but it was one of my really big systems.
Yeah.
There's just crazy stuff with huge solar panels and supporting brackets and, dishes and all sorts of stuff.
Yeah, wow.
Infrared lights so the cameras could see. And it was just huge battery banks. So I'd say the camera industry's probably been the most advanced.
Okay.
Whereas now, I can run some of these cameras off some of my smallest energy storage modules. Whereas before I'd needed a really big system to do that.
Yeah, okay.
We're getting clients come to us now, like I said before, long-range Wi-Fi extenders. They have to be specifically put. So they're ideal for our industry because we can just put it exactly where it needs to be. Whereas 10 years ago, you couldn't have powered one of those. They just drew too much power.
Yeah.
Another big one would be data servers. So we're getting clients with what's called embedded servers. So they are ruggedized, hardened servers. And back in a previous life in defence space, you could get them, but they were horrifically expensive and were pretty limited in their power. Now they're really powerful, run a lot of AI models, and they fit. They can fit in your hand. We're about to get blown away again, are we?
See how we go.
You can fit them in your hand. Like now, you can fit them in your hand, and we can power those, and that's being used everything from signal processing to advanced cameras, AIs, or sensor suites around the world as well. So definitely seeing that transition. I think we talked about it in a previous podcast was people see us as a lighting company, but we're more that reliable nano sort of grid energy company these days. Yeah.
So that's kind of where we're at now, right? We can do all those things and power cameras, Wi-Fi, a whole bunch of other things that we couldn't do 5 years ago.
Yeah.
Well, it was more difficult to do 5 years ago. I suppose as a business, you as the founder and CTO have been very good at looking into the future. Trying to understand what the demand might be, 5 or 10 years from now. And that's got us to where we are now. Outside of what we do today, powering those things, do you see solar and what we do powering other devices or other things now, and how it's going to change in terms of whether it's devices or connectivity or how we associate back to the grid, or how do you see it evolving?
I think it's one of the things that in the future I see is the power pole, the pole that everybody takes for granted when they walk down the street. And whether it's holding a telephone wires or power wires, or maybe it's holding a light, that's going to be the asset of the future, because it's out of the way, it's up high, and because of all those things, it's a great place to hang things. And as we've all seen with the evolution of AI and all the gadgets and sensors that we have now, I think the future is AI. People think as AI is working in a cloud model, right? A giant supercomputer under the water or in the sky, right? I think most of the work with AI will be at the ground level. It's sensors. It's the human-centric side of what it is. So when you walk down the road, the future will be some sort of sensor detecting you for your own security or the security of others, and everything from cameras to environmental sensors to whatever. Now, they're going to have to be put in locations. They're going to have to go everywhere. And back to our original model, people really buy us when there's no ability for grid tie. So I believe in the future that the power demand will become so small that more and more solar-based energy storage systems become more feasible.
Right.
But then they'll need to be more geographically dispersed and put in locations where the grid doesn't go. So I see the power pole as being a very valuable resource. And in future, people will probably be selling information off of those poles, whether we like it or not.
Right.
And Green Frog wants to be that trusted micro nano grid energy company that's just powering that device really, really well. Without any other interference from the grid or et cetera as well.
And I suppose you spoke about earlier the battery being the piece of technology that's evolved the fastest. So in the future, if we are in those places, those really remote places where there is no grid-tied power available, and more abundant, I suppose. That battery, how much more developed does it need to get from where it is today to what we need it to do?
Yeah, I think there's two ways to answer that. One is you'll have the economic version of the industry. So that would be more, it doesn't matter how big the battery is, I can just put more of them in to get the capacity I want. And we're already seeing that with home storage.
True.
You can go get a 50 kilowatt battery and it's this big, or you can get one that's kind of this big, but this smaller one's twice the price because the energy density is higher and it's also more complex. So I think you're going to see the prices come down for the price of power per watt, as in the industry, that's what we buy. And then you have different classifications for reliability. So you'll find you'll be able to buy bigger systems. And then when you're looking for integrated systems or custom systems where the battery will be molded like, wrapped around a pole, or batteries will become integrated into the things that we wear, they'll become special high density type solid state batteries, which will initially be more expensive, but as the technology gets better, that will evolve. And so we'll start to see that into our light fixtures. We'll start to see that integrated into products, and you'll be like, where's the battery? And it's actually part of the skeleton.
Right.
So that's pretty much the future, and we're starting to see that already.
Interesting. So I know you love cool technology, right? Who doesn't? But you in particular, what else do you see coming for the industry in terms of technology that may be in its infancy right now and not yet commercialized?
Yeah, I think it's probably the interconnectivity. You'll start to see more individual pieces start talking to each other more. So one of the big ones that people are already starting to see would be 10, 15 years ago, if you'd have said, oh, my battery's talking to me, my Bluetooth, you'd go, what? Whereas now, that's pretty much mainstream. So I think it's the interconnectivity between all the devices and the commonality across them all. That's probably where that will enable a lot more innovation in space. You'll also start to see a lot more embedded AI. So we call that edge AI. So it's AI embedded into the device and makes its own reasoning. So it doesn't have to go to a giant server up in underwater or whatever to go, hey, what do I do with all this data? It's embedded into it with a very specific purpose. So for example, our controllers will have, and we're working on embedded AI in them, where it just does solar processing really well. It goes, what did I do yesterday? What did I do the same time last year? What is my trend for the month? What am I likely to expect energy-wise? And then that's talking to the AI processor and the battery. So you'll start to get a lot more localized efficiencies, I guess.
Right.
And then very small bandwidths of data going back up to the cloud. We're already working on a really cool satellite-based one as well. For the same thing. It's we'll do most of the processing works with our edge AI, and then just send tiny little bits of information up for the cloud AI to do the big crunch numbers.
So it really seems like the business has gone from providing solar lighting to the industry effectively. Fast forward 15 years, we're now powering many other devices more efficiently, but also the data that's been collected and potentially then useful for other applications seems to be very important.
Yeah. I think that's one of the, we're going to get Tim from Acrospire in the UK to come on. And one of the reasons he was able to really evolve that industry in the UK for solar was he could rely on us for the data.
Right.
We just had years of data, and we were able to combine. We work with them for data collection points across the UK. We could see what they could see, and then we were able to build that into models, and then build algorithms around that to control things. So definitely data is key, and it's one of the things I see. I see people coming all the time to try and do what we do. And they go, oh yeah, we can just put a battery on there and a solar panel and whatever. We can do what you do. And it's actually part of the reason we're one of the only companies that's still around doing this, because it's reputation risk.
Yep.
People actually remember us when it's not working. They forget about you when it's working, and that's what you want.
Yep.
So as a company, we're really trying to build that model. You can forget about us, it's okay, because we'll still be working.
Yep.
Because, it's not just our reputation, it's the power partners. So say we're working with a camera company or a Wi-Fi company or even some of the really big lighting companies in the world. They're going to be the ones that get the phone call.
That's right.
And so our job is to make sure that they don't get that phone call.
And you touched on the satellite data before, and with what you guys are working on right now, we'll be able to tell the customer if there is a problem with one of their cameras or sensors or whatever it is, right?
Yeah,
Which is really cool.
Yeah, that's very cool. Yeah, and remember I was talking before about this little AI module. We'll talk to that AI module. That's where the real power was, because then we're sending very small bandwidths of data up, which can happen more frequently and also cost the customer less, because data costs money. And so that whole ecosystem is being built, and it's pretty cool. Yeah.
So to put you on the spot, the defense industry, obviously we have some very cool technology. What application could there be with the defense industry, whether it's here in Australia, across the globe, in the US, where we also operate?
Yeah.
How could they benefit from that?
As across most industries, you see the electrification of the industry. There's, I think, a couple of the new tanks are electric tanks, battle tanks and things like that. And we're not at that level. Don't say, well, I'm pleased, I'm not going to be solar powering a tank anytime soon. But there are lots of other devices, everything's from drones to field sensors that are going to need some sort of advanced power management. And I think that's a big opportunity in the industry. But again, one of the things that I've seen, and this is part of the reason we've got years of development, was I can go buy a controller and it's got a data sheet that says it can do everything. But when you are in mission critical, safety critical applications, that will only work if you've got the data behind it and the R&D and the engineering. And so for us, it's about building the next generation controllers that are deliberately over-engineered, so that whether you are putting a light in the middle of America where it's 4 hours to do any maintenance, or in the middle of Australia on the Stuart Highway where we've got all our lights, the most important thing is to build you some controllers and the associating technology that is over-engineered, that is just going to last the environment. So really the stuff that we do now naturally falls into defense or even some aerospace technologies or mining.
True.
Falls in really well because it's the same sort of field work.
Well, Dave, that's probably all the questions I have for you on tech for now.
Sure.
There'll be a bunch in the future, I'm sure. But thanks for coming on. Thanks for
good.
sharing your insights.
Yeah, we survived the cyclone coming through the building.
I know, right? I think it's just starting up.
Cheers.
But until next time.
Yep. Thank you.
Thanks.